All assembly language instructions work with register size bytes of data, 8, 16, or 32 bits, but there are times when you want to copy a larger block of data from one place to another. This is done in a loop, 1 byte or 1 word at a time, and some special instructions can be used to make the operation as efficient as possible. This code snippet will copy a 50-byte block from the source to the destination. But to do that, you have to set things up first. This instruction clears the direction flag. Now it's important that you do this because the flag is actually a part of the two opcodes used to copy data. More about that in a minute. The source of the first byte to be copied is loaded into the ESI register, the source register. The address of the first byte to receive data is placed into the EDI register, the destination register. Now to keep these straight, just remember that SI stands for source index and DI stands for destination index. The only thing left is to set up a counter. This is the number of bytes to be copied. In this example, it's 50. The rest of the code is the loop that does the actual copying. The LODSB instruction copies an 8-bit value from the source into the AL register and then adds 1 to the ESI register. The STOSB instruction copies the AL register into the destination, then adds 1 to the EDI register. The loop instruction, which you've seen before, subtracts 1 from the ECX register and branches to the top of the loop if the result is not 0. To see how this works, let's take a closer look at the load and store instructions. These two instructions were originally conceived to be used to be string operators, so they are short for load string byte and store string byte. Now, another way to write code that does the same thing is with these 4 instructions. But depending on the flag setting, the instructions can actually do something entirely different. They could actually subtract 1 each time from the index registers, effectively changing the direction they iterate through memory. That's what the direction flag setting does. The CLD instruction clears the direction flag, and with it cleared, the load and store instructions will add to the index registers. The STD instruction sets the direction flag, and with it set, the load and store instructions will subtract from the index registers. Now it's important that you don't forget to set the flag, because if you don't, your code may or may not work, and even worse, it may work sometimes and sometimes not, depending on how the flag happens to be preset. There are 3 load instructions and 3 store instructions, a pair for 8-bit data, a pair for 16-bit data, and a pair for 32. Notice that they all add or subtract the index registers according to the size of the data. You just have to remember to adjust your loop counter for the size of the data items. For example, if you want to copy 80 bytes using the double word version, you will only need to iterate 20 times. Now these instructions can be useful if you need to do something to a block of data. For example, if you want to change a string to uppercase, you could do that in between the 2 instructions because the character is held in a register between them. If you just need to copy a block of memory from one location to another, you can use one of the move instructions. They actually copy directly from one memory location to another without bothering to put the value into a register. Look at this. This code does exactly the same thing as the previous example. The only difference is that the load and store instructions have been replaced by a single move instruction. In this example, the AL register is not involved. More about all this in the next lesson.